Today, the greatest common divisor, made easy. Here's a typical test or exam question. Or you might see it in this form, or maybe in this form. Before we solve the problem, a couple of comments about the GCD. If we look at the GCD of 6 and 8, well, the D tells us to look at the divisors, which you can see here for both 6 and 8. The C stands for common, so we look for common divisors, which in this case are 1 and 2, and G stands for greatest, so we look for the greatest common divisor, which is 2. Now this method works very well for small numbers, but for large numbers it's difficult to find the divisors. So if you saw this sort of problem, for example, it would take you many hours using a calculator, pen and paper to work out the GCD. Euclid's algorithm is terrific because you don't need to work out the divisors to work out the GCD. Okay, now to the problem. Using Euclid's algorithm, find the GCD of 7398 and 2877. So we use the two numbers that were given in the problem and we set it out as follows. We have 7398 equals 2 times 2877 plus 1644. The remainder theorem ensures that we can always do this and have a remainder, in this case 1644, that is less than both of the original two numbers. Now here's the really beautiful part about Euclid's algorithm. It was observed and proved that the GCD of 7398 and 2877 is exactly equal to the GCD of 2877 and 1644. You can prove that that's always the case. I'm not going to do the proof because I'm trying to make this easy, but if you look up on the internet you'll be able to find a proof of what I've just said. And at some point I'll probably do a proof of Euclid's algorithm made easy video. Now this is substantial progress because it's turned the problem of the GCD of 7398-2877 into a GCD using smaller numbers, in this case 2877 and 1644. So it's a little bit easier. Then the bright idea was, well, why not just keep doing this? So we can say that 2877 equals 1 times 1644 plus 1233. And so now we've made the problem just working out the GCD of 1644 and 1233. Now let's repeat it again. At every stage the remainder is going down, it's getting smaller. So the next line is 1644 equals 1 times 1233 plus 411. Let's do it again. 1233 equals 3 times 411 plus 0. If you think about it, as the remainders get smaller and smaller, eventually we must get to 0. So this is telling us now that the GCD of 7398 and 2877 is the same as the GCD of 411 and 0. And the GCD of 411 and 0 is just 411. Now, normally people will argue it slightly differently. They'll say the remainders get lower and lower until you get to the last non-zero remainder. So they'll tend to focus on the second last line where we had 411. And they'll say then that 411 is the GCD. So the answer to our problem is 411. That's it for the greatest common divisor made easy. I hope you found it useful.